This is lesson 26. We are going to talk about percent rate of change, and we're going to use our idea of growth and decay and rates to apply our knowledge to more real life problems. So say you have a youth group and we have a yard sale, kind of like we had a big sale to raise money for homelessness. And the group earns $800, but decides to put the money in the bank for the while instead of just like letting it sit there. We want our money to work and accrue interest so that we get more money. So the local bank pays an interest of 3% per year. 3%. So in your notes, you should definitely be pausing, writing $800 starting, and then 3% interest, or 0.03. And the group decides to put all the interest they earn back into the account to earn even more interest. So our goal is to determine the explicit and recursive formulas for the first 3 years of the account balance. Something about this interest. Let me tell you how this works. So we start with $800, and then they're going to put a certain portion of your bank account, 800. They're going to put 3%. They're going to add 3% in to your bank account. So this is going to end up being, let's factor out 800. It's going to be 800 times 1 plus 0.03, and it's going to equal to 800 times 1.03. Both of these scenarios are going to show up in our calculations for our real life problems. So I want you to be familiar with where this is coming from. This is going to be our common ratio. And then this you might see in our formulas, 1 plus our rate or 1 minus our rate. So that's coming up in the future for you. Let's calculate the first 3 years with 3% interest. So at year 0, we have $800. You're going to write down this whole table. At year 0, we have $800. At year 1, we're going to have $800 times 1.03. We're 1.03, all of our money back, and then 3% of that. So we're going to get 800 times 1.03, which is 824. 824. So that means we start with $800, we multiply it by our common ratio, and we get 824. That's great. In year 2, you're going to get 824. In this column, we're going to put the previous term, which means it's going to be our recursive formula, 824 times 1.03, which is going to be 824 times 1.03, which is 848.72. 848.72. So for each year, in the second year, we're going to multiply this interest rate 2 times. Second year, multiply the interest rate 2 times. That makes sense. In year 3, we're going to take our previous number, 848.72, and we're again going to multiply it by our common ratio. So times 1.03. 874.18. In this case, we're going to multiply by our common ratio not once, not twice, but 3 times in order to get 874.18. Let's write the number, the formula in M years. I'm going to get rid of this guy. In M years, we're going to take our balance at our previous year, whatever our previous year was, whatever M minus 1 was, and then we're going to multiply it by 1.03. That's our recursive formula. Our explicit formula is going to be our starting balance, 800, times our common ratio to whatever year we want. Whatever year we want, we're going to plug it into M, take that as the exponent, and then multiply it by 800. So at the end of the year, we're going to have $874.18. Let's see if we answered the questions here. Yes. Let's move on to the exercise. We only have 2 questions. The first one takes a little bit of work, and then the second one doesn't. Oh, let's go back first. Here, So what is our formula? Our formula for interest is going to be our principal, our starting balance, plus our rate, 1 plus our rate, at a certain number of years. I don't know if Engage New York uses M or T. I can't remember at this point. So this is our output. Principal is our initial value. 1 means we get all the money back. So our function is increasing because it's greater than 1, right? We know that our B term, the function will be increasing, which means we're getting our money back and then some. And this is the rate of interest. And this is our input, or number of years. So let's use this in our next problem. A youth group from the opening exercise, they started with $800, is given the option of investing their money at 2.976% per year, compounded monthly. So it's not 3% per year, it's less, but we're going to do it 12 times over the year instead of just 1 time over the year. So if we do this 12 times in the year, we potentially could make more money. So let's see. After 2 years, how much would it be in each account? Okay. So let's not make a table and let's try to use this formula. Here's the thing though. You're going to hear this term APR, and this means rate per year. But we're not doing this once a year, we're going to do this monthly. So in this case, we have to take our rate and divide it by the number of times unit rate that we are going to get interest. So in this case, our rate is 0.02976, and the number of times we are going to compound our money is 12 times in the year. And we're going to do it for 2 years. So this is going to be our I, or our unit rate. If you have questions on this is where you ask your teacher the next day, because this is going to come up a lot. Okay, so let's try this. Our funds are going to be our principal amount. That's our P value. We are increasing in our money, and our rate is going to needs to be compounded monthly. That means we're going to do this 12 times. So that means the yearly rate, the APR, needs to be divided by 12. Now, we need to, instead of just, what term did I use? M? Maybe I should have used T. Instead of just M, we're going to plug in 2 for M. But we're not doing this 2 times. We're doing this monthly times over 2 years. So we have 12 times 2. So let me show you how I plug this into my calculator. I get to about this point, and then I'm going to calculate it. So, oh gosh, there's a 2 in here somewhere. Okay, 0.02976 times, or divided by 12. I'm going to do this part first. I'm going to do inside my parentheses first. Plus 1 raised to the 24th power, and then times my principal. So I just did my order of operations. So then I got $849. So if I compounded monthly, I get $849. This was our original number after 2 years. This was from your table above. This is if you compounded it yearly at 3%. So if you want to make like 20 something more cents, compound monthly over yearly. Oh yeah, this video is about saving you big bucks. Oh, that was part B. Compare the total amount from part A and how much you would have made in 3% over 2 years equals 848.72. And then monthly, which we just calculated, was $849. So tell that youth group, we're going to take our bake sale money and we're going to invest it monthly. That's all I got for the video today. It's going to get, the details matter, so pay attention to the details in class and ask lots of questions that I'm pretty sure your teacher can answer. So bye, everyone.